Okay, guys, welcome back. This is the second video that I have made for you. We're going to talk about lists in memory today. I unfortunately couldn't finish going over this during last lecture, so hopefully this will clarify some things that I had in my code. Um, okay, so as you know, my name is Nenad, and this is our staff. And we talked during last lecture about lists and list structure. So the element of a list are the square brackets. So this is how you make a list. An empty list would be just fruit equals and the square brackets. And then we have the elements of the list that are separated by comma. Those elements, as we said, can be strings, they can be other lists, they can be tuples, they can be um, um, integers, floats, dictionaries, etc. You can store any kind of stuff in lists. And we have also the list name that you can choose, and it should be always descriptive depending on what you're storing in those lists. And finally, these are comma separated elements. All right, so I'm going to talk about several topics right now um, that you may find very interesting. So first, we'll talk about how we can copy lists and how lists behave in memory. We'll talk about two interesting concepts, which are the shallow copy versus a deep copy of a list. And then we'll see some interesting things about list elements and interning. Finally, I'll just briefly mention list comprehensions again. I'll give you another example of that. Okay, so this is my Jupyter notebook. Let's open Python. And so we know that by now, this was also on the quiz, that if we make this variable and we store some kind of integer here, let's say 15, right? And we say that b equals a. Then at this point, we know that these two are referencing the same object. So there's going to be an A and a B, and these references are going to both point with an arrow towards the value 15. We're only going to have one copy of 15 stored in memory because these integers are going to be intern. So um, we only have one copy for both. So we can make sure that that is true. So we can print B, and B indeed is 15. Great. So one of the things we did on the quiz was that we changed A. Okay, and we can change A to Google. So now we can print A and we can print B. So now A is Fugu, but B is still 15. That's because all we did was we put Fugu somewhere in memory, and now we move that arrow that A was pointing towards 15 to that. B is still pointing to 15 at that point, so B is still referencing 15. So this is important to note, and so we're going to talk a little bit about uh, how this works for lists. All right, so we know lists now. We know how to make lists. Let's make a list called names. Okay, and names can be Adam, Jane, and George. Great. So we know that this list has 3 elements. If we wanted to check that, we can just say, all right, how many elements does this list have? It has 3 elements. Great. I'm going to silence these things with a comment so we don't get confused. We have 3. Great. I'm going to silence this too now. So um, I'm going to make another list now. I'm going to call it names2. And I'm going to say that names2 equals names. So the question right now is what did we really do? Did we do the same thing as here? So we can check that, right? So we can check whether um, names is equal to names 2. True. So that's interesting. Let's see whether names is names 2. Yeah, that seems to be true as well. So, but you might ask right now, okay, but you did the same thing. So you said equals equals, which gives us true, or you used the Python keyword is, which also gives you true, and that's kind of the same thing. So why are you doing that? Well, actually, doesn't uh, that is not true, because these are not the same thing. So the equals equals sign is going to check whether those elements um, look the same. So let's say you have a list that has 1, comma 2, comma 3. It's just going to check whether those elements are identical, so whether they look the same. But what is going to do is it's going to check whether that is exactly the same object, so the same object in memory. Okay, and we're going to understand how this works really quickly right now. So this is not too complicated. So all right, so now that we've made this list names uh, equals Adam, Jane, and George, what will happen to names2 if we were to change the first element to, oops, sorry, I think the first element to span. We're going to print the list names, and actually, let's do it simpler. Okay, I just changed it. I instead of inserting another list, I just changed Adam to span. Okay, so now what happens to names2? Is names2 going to be different or the same? What do you think? It's going to be the same. And why is it the same? Well, we know that lists are mutable, and we're making an in-place change. So we're not really changing names2, okay? We're not changing names1. What we're changing is the object that is stored in memory. So we're changing that object in place. Names and names2 are just referencing that object. And because they're referencing exactly the same object, um, when we change that object, whether we call names1 or names2, um, it's going to change. So we're going to observe the change in both. So this is kind of like giving something the same things separate nicknames, and then but that thing, that object that you're referencing is the same object. So how can we make sure that this is the case? So we can do something like, well, why don't you tell us what is the ID in memory of names? And that is this number here. Well, how about of names2? And lo and behold, it's the same number, because this is exactly the same object in memory that we just changed here. We changed this value to this value, but it's still the same object. Okay, so, but you might want to ask, well, what if I wanted to make a copy of this list, uh, and I wanted to have a separate copy, and I want to keep the original, let's say, for whatever, and then I want to do changes on um, the second uh, list that I copied. So you can do that. Okay. So we showed how to do this in class. Let's say we have, I'm going to make a new list of integers. Just a simple list. Let's say 1, 2, 3. All right, 4, 5. Great. And let's call it list, just so it's simpler. List 1. Okay, so if I wanted to have list 2, how would I copy this? So I can do something like list 2 equals list 1, and then I can use the slice notation. So when you create a slice, you're actually slicing out a list. So if you create a slice from the beginning to the end of a whole list, then you just get the whole list back. Okay? So now, let's see what happens. First of all, our list 1 and list 2 the same as far as elements go. Do they have the same elements? Okay. And yeah, that's true. Okay, so these lists look the same. As far as contents go. Now, here's the big difference between is and equals equals. So what do you think is going to happen if I ask, is this the same list? So is checks whether that's the same object. Do you think they're the same object now? Because we made a copy. Is it the same object? Is this going to be true or is it going to be false? And it's false. And it's false because we just made a copy of this and we stored it in a totally different location in memory. I can prove that to you. So let's print the ID of list 1. I still haven't had my coffee today. And then print the ID of list 2. All right, and here we go. Different, right? That's kind of interesting. So we made a copy and we make a copy. That means that these are separate. Now, the question is, now, what happens if I'm going to silence these? But when you go over the code, feel free to, actually, why not? Let's keep that. It's not too much output. It's not going to confuse you. Let's go on. So what's going to happen now if I change list 1 at position 0, right? So we're going to, that's this thing. We want to change it to spam. Okay. And let's just confirm that we did that. Great. So lists are mutable. We reference this by location by index, and we change that value to something else. So if I were to print list2 now, is this going to change? Are we going to have spam in list2? Print list2. And no. And the reason that that's no longer the case is because here we copied it, and we copied it to a new location, and now when we changed list1, we only changed this, which only list1 points to. List2 points to a completely different place in memory, and therefore now we have a method to preserve the original list, and we've only changed the location where list1 is referencing to, but list2 now has the copy, and that one stays unchanged. Okay, so that's great. I think that's pretty clear. Now, the question is, what happens? Actually, you know what? I'll come back to the shallow versus deep copy, because something else is a slightly more interesting immediately, I think, here. So, okay, so now we have list1, which is spam 2, 3, 4, 5. Okay, so I'm going to make another copy. I'm going to make list 3 equals slice of list1. So I'm going to copy list1 into list3 again. So now, oops, what did I do? Oh, yeah, of course. There we go. So let's print list3. Okay, we made a copy. And we know now that from here, we know that these are going to be at a different ID. So they're in different objects. So if we print the ID of list3 and comma ID of list1, they are indeed different. But how about, what do you think is going to happen if we print the ID of list3 at position 0 and list1 at position 0? All right, so we're checking the ID of spam, right? So both of these lists are two different objects, okay? And they have the same elements. So if we were to do, which means that if we were to do equals equals, it's going to be true, okay? But if we were to do is, it's going to be false because they're two different objects. So what do you think this is going to be now that these are two different objects? Well, it's going to be the same. That's kind of strange, isn't it? But actually, it's not that complicated to figure this out now, because we already know what's happening. So remember, I told you that Python is interning strings that don't have white space and certain integers, and it just keeps them in the same place in memory. So here's a perfect example of that. So here is a list in two different objects, but yet spam exists. There's only one copy of spam in memory. So imagine if you had like hundreds of thousands of lists and you're doing something like that and spam was there. Python is smart enough to only still keep one copy of spam. So this is the reason I wanted to show you this so you can see how this interning works in memory. And you can see here that spam in both of the lists, even though they're two different objects, um, is interned and there's one copy of spam in memory. That's kind of cool, isn't it? All right, so now let's go back to this copying of lists stuff. Um, so we learned how to copy a list. We can use the slice notation. The slice notation is a very common way to copy lists. Everybody's doing it. But you have to be careful about something. So when you do a slice copy, what you really do is you're creating a shallow copy. But before that, let's go over several different ways of copying lists. So I'm going to make list 3 here. We made list 3. We're going to make list 4 here. Okay, so list 4 equals, and I'm going to make a list out of list 1. Okay, so that's another way of copying a list. So if I were to print list 4 now, and list 4 copied the contents of list 1. And the reason that we have spam is that we're changing list 1 right here. Okay, so now let's see if this is a different object. So we can, I'm just going to steal this from here so I don't retype it. And they are different objects. Okay, so we did make a copy. Okay, so this is one way, slice notation. This is another way, by typecasting, right? And there are two other ways. And for that, you're going to have to import something. Import, I believe it was import copy and deep copy. So there's two different copying functions that we can use to make a copy. So what do they do? All right. So I'm going to first use copy. I'm going to make yet another list here. It's going to be list 5 equals a copy of list 1. And let's print these. Okay, different IDs. I copied the list, and this is a success. And you might wonder, well, why do we need something like this? Like, why do you need copy? Like, why can't we just use this all the time? Well, in Python, there are other different types that are not necessarily sequences. And this slice notation, for example, will not work on sets and on dictionaries. So this is why you should be aware of this copy module and the copy function. So you can use this for specifically with dictionaries and sets. You're not going to have other choice. You're going to have to copy them in this way. So yeah, so this is here is another way. But the thing that to keep in mind is that now we keep making something called shallow copies, and you may wonder, well, what is a shallow copy? So this prepared to be a little bit confused, but um, um, let's do something a little more complicated. So we're going to make a list of numbers. And then in that list, we're also going to have another list that has some other lists of stuff. Like, for example, it has the name John. And this one here has the name Anna. All right, so this is a list, and it has 4 elements, 1, 2, 3, and this list of lists inside, right? So let's say that now B equals, we're just going to copy this. Let me convince you that this is the case now. So actually, let me see if I can do this. I'm going to split this cell just so run this here. I'm splitting this just because we don't want to see all this output here. So we're going to print B. All right, we copied it, right? We copied it. We can print the ID of A and the ID of B. They're going to be the same ID or different? They're going to be different. Excellent. Now, let's change. Let's change. Well, let's change. We're changing the 4th element, right? Because it's index 0, 1, 2, 3. And then we're going to change the first list, which is the 0 element. And there we're going to change the, okay, so we're going to make that at position 0, there we have John, and we're going to make that equals to Sam. Okay, and let's print A now. All right, so we successfully changed this. Let me go over that again. So you have 0, 1, 2, and 3, right? So we're accessing the list of lists. In that list of lists, we're accessing the first list, which is index 0, so that's 0, that's 1. And in that list, there's only one element, but that is still at position 0, so that's why we have 0. So we went basically three layers inside, then we changed this thing. Great. Now, what happens if we print B? Okay. That is weird, isn't it? Right? Because these were different objects now, right? So we copied it. We know they're at a different location. And we changed it. We only changed A, right? And well, let's see what happens if we only change the first value of A here. Okay? We're changing the first value of A. That's 1, right? We're going to change it to 5. Watch what happens to B and A here. Weird, right? So we changed A to 5. But when we changed here, this nested element, it also changed it in B. So that's the difference between a shallow copy and a deep copy. So in a shallow copy, you're going to copy all the elements in the first foremost layer, right? But all the rest of them are not going to be copied, they're going to be referenced. So you're still referencing from the first list, from A. B is still referencing all of the nested lists here. So if you want to, for this behavior not to happen, if you really, really, really want to copy all nested layers and to make a totally different copy, you're going to have to use deep copy. All right, let's use that. And by the way, so if I use the slice notation here, okay, this is the same. If I made a copy of A, okay, or if I made a list of A, I'm going to prove to you right now real quick. I'm going to turn this off, execute again. Let's see if Sam is going to stay here. Yes. So we're still changing it. So again, shallow copy. Now we also know that this is a shallow copy. Okay. Let's see if this is a shallow copy. This is a shallow copy too. And now let's make a deep copy. Oh, I misclicked, sorry. All right. I'm making this list, 1, 2, 3, with a nested list. I'm making B to be a deep copy of A. Okay? They're going to most certainly have different IDs. They're going to be in different objects in different locations. And now I'm changing in A, I'm going to change John to Sam. I'm also going to change 1 to 5. And let's see what's going to happen to A versus B. Now, you can see that because of the fact that we made a deep copy, even the internal elements, those nested elements in these lists, got copied, and those live in a separate place in memory, and therefore when we change this, they're no longer referenced from A. And then when we change John to Sam in the first list A, we did not change it in B because we made a deep copy. So I hope this was kind of interesting for you. I hope you understand at this point what equals is and what is, and how you can use them differently, and make sure that when you use them to keep this in mind, because they are not doing the same thing. They're not the same thing. So make sure that you understand what shallow copy and what deep copy is, because most certainly that's going to be on the quiz and on the exam. So you should know if we make a shallow copy and we change a nested um, uh, element, that what are going to be the consequences of that in the list that stores a copy. Okay, so now we know that this would be just in a shallow copy, these are referenced, and then they will actually change, and in a deep copy they will remain the same. Okay, so finally, what do we have here? Yes, so we have list comprehensions, and I briefly went over this, and list comprehensions are very powerful. And we have 3 elements of list comprehension. One is going to be your output expression. The second one will be your iterator, so it's going to be a loop. And finally, this is an optional one. You don't need this element, so it will be your optional predicate. So in your iterator, you will have your variable that lives in your for loop, and since we're using list comprehensions to make lists from other lists, we're going to iterate through that sequence. Actually, not necessarily other lists, but it could be a tuple or so on. But we're going to iterate through that sequence, and we're going to do something report something for every element in that sequence with the output expression. And the optional predicate is if we want to check if something is true or not for every one of those variables in that sequence that we're working with. All right, so let's do something. I think I did something more complicated in class, but we can do something simpler. So let's say, let's say I have a list of numbers. So I can make a list of numbers from 1 to 11. Okay. And we know that with range we can generate any kind of list of numbers. Here we go, from 1 to 10. So if we wanted to use a list comprehension, let's say we wanted to filter this, or let's say we wanted to multiply this list by something. Let's do something with all of these numbers here. So I can just say b equals, let's say x times x divided by 2, something like that, for x in a. Okay, so this is our iterator. For every x in a, I want you to return this thing. Okay, and I'm not checking for anything. I'm just going to execute this. And if we print b now, we have performed this operation. So this might look a little confusing for you when you look at it the first time. A very good way to look at them. So we know what are the essential elements, and like these are the, you have to have something that returns, right? But the best thing to do is, when you want to identify them when you read code, is to just look at the iterator first. So just find it where it starts, like find where that 4 is, and see first how you're iterating through something. Okay, so then you see, okay, so that means that if we're doing for x in a, that means we're going to have to do something for x. So then we go back to the left side, and that is like, so what do we do with x? And that's a very easy way to look at list comprehensions. So now to this thing, we can add, well, I don't want to do this for every number here. I want to only do it for the even number. So I can say if x, we know this by now, modulo 2 has a remainder of 0, right? Because this will only be true for the even numbers, because 2 goes perfectly in every even number without any remainder, because 2 modulo 2 is 0, 4 modulo 2 is 0, and so on and so on. But for every odd number, this would be, if we wanted to do it for every odd number, we would have to do this, because for every odd number, we would end up with a remainder of 1. Okay? So if we do this, we're going to get half the results, because we're only doing it for the even numbers. And then basically here we have 2 times 2 divided by 2, which is 2. Then we have 4 times 4, 16 divided by 2, which is 8, and so on and so on and so on. So this is list comprehensions, and they can get a little more complicated, and we can talk about a little more complicated list comprehensions later. But I think for now, you should practice with just this simple syntax, and I think you can definitely make your code a little bit shorter, and they will work for you pretty well, I think. So feel free to use them. Um, and I'm looking forward to see some of your homeworks problems be solved like this, because it just looks a little bit cleaner. And somebody asked me last lecture that they thought that list comprehensions are not very Pythonic, and so yes and no. I think that for something like this, it's perfectly clear what we're doing. But if you are to do something that is very, very complicated, that has maybe nested for loops and kind of complicated checks, that this thing grows to be very difficult to read, then you should think about whether you're sacrificing too much readability, whether somebody's going to have to sit there and try to decipher this for half an hour, like what you actually are trying to do. At that point, it becomes not Pythonic. I think that, but for stuff like this, I think it's perfectly fine. And like I said, so we generate a list from any kind of sequence. So you already, when you use this, you already have some kind of a thing you want to iterate through that's in a sequence form. Um, they're perfect for filtering things out, for doing checks on everything, in lists and tuple strings and so on. So I think that you're going to have fun using them. All right, so I hope you have a great long weekend. I'm going to work on the quiz now. Um, I hope that you're keeping up with your studies, uh, and uh, and please ask questions. We're here to help you out. There's plenty of time for homework too, for PSET too, so please don't leave it for the last couple of days. And let's get that done. All right. Hope you enjoyed this presentation, and goodbye.